Hello, friends. I welcome you all to Only Code. I'm your host and host, Rahul. Let's get started. We will discuss about advanced collection concepts in this video. We will take a closer look at why generics are used in collections and how they improve our code. Then, we will move on to iterating through a collection and we will explore the collections class in Java, which provides useful utilities. We will also cover thread safety in collections, which is crucial when dealing with concurrent programming. Finally, we will discuss performance considerations when working with collections. Let's get started. Let us now look at the importance of using generics in collections. Generics are a feature in Java that enable you to define classes, interfaces, and methods with type parameters. This means you can specify the type of elements that can be stored or operated on within those collections or methods. For example, instead of using a collection that stores objects of any type, with generics, you can define that the collection will only store elements of a specific type, such as string, integer, or any other class. This ensures type safety at compile time. In simple terms, generics let you work with specific types without losing flexibility, and it prevents you from accidentally adding the wrong type to the collection. See the below example. In this example, the list is specifically defined to hold only integer objects, and trying to add a string result in a compile time error. The key benefits of using generics in collection include type safety. Ensures only the intended type of objects can be added to a collection. Reduction in runtime errors. You cannot accidentally insert the wrong type of object. No need for casting. When retrieving an element, you don't need to cast it because the type is already defined. Improved code clarity and reusability. Generics make your code more readable, flexible, and less prone to errors. Let's create a list of numbers with generic type integer. Numbers equals new array list. The generic type of integer here specifies that only integer elements can be added to the list of numbers. Numbers.add 1. If we try to add anything except an integer to this list, it will throw us a compile time error. Numbers.add hello. We can see here we have a compile time error, which says that the required type was integer but provided string. In this way, generics help us maintain type safety. All the methods that we have discussed for all interfaces are also applicable with the generic types. Iterating through a collection. The first method for iteration is using an iterator. An iterator allows you to traverse through a collection and provides you with more control over the iteration process, even allowing removal of elements while iterating. The iterator interface provides three main methods that allow you to traverse through collections. First method is has next. Checks if there are more elements left to iterate in the collection. It returns true if there is another element, or false when all elements have been traversed. Next, retrieves the next element in the collection. If there are no more elements to iterate through, it throws a no such element exception. Remove removes the last element returned by the iterator. However, this method can only be called after next has been called at least once, and it cannot be called twice consecutively without calling next in between. Violation of any of these cases will result in illegal state exception. The for each loop, also known as enhanced for loop, is another way to iterate through collections in Java. It simplifies the process and is often easier to read. It automatically traverses the collection without the need for manually checking or managing the iterator. It provides a clean, concise syntax. Unlike an iterator, the for each loop does not have explicit methods. It automatically accesses each element one by one and makes the iteration process simpler and more concise. You don't need to worry about managing an index or calling methods to get elements, which makes it a cleaner and more readable approach. The for each loop is ideal when you simply need to access each element in a collection and don't need to modify the collection or control the iteration process in a more granular way. Consider a list of integer nums equals new array list. Let's add few elements to this list. 1 and 2, 3 and 4. Let's try to traverse this list using an iterator. Iterator of integer iterator is equals to nums dot iterator. First we have to check if the iterator is having any elements or not. We will use a while loop to check if iterator is having a next element or not. This will be true until we reach the end of the list. Integer current num is iterator dot next. And finally, we'll be printing this current num. We can see the whole list is printed using the iterator. Let's say we would like to remove the element 3. If current num is 3, then we will use iterator dot remove. And if we print the whole list at the end of this operation, in the midway we have removed element 3. So we can see at the end of the loop only 3 elements are present in the list 1, 2 and 4. Let's also use the for each loop to traverse through this list. For each integer num in nums, we will just simply print num. You can see that using the for each loop we have printed the list 1, 2 and 4. Collections class in Java. The collections class is a utility class in Java's collection framework. It provides a set of static methods that allow you to perform common operations on collections, such as sorting, searching, and creating thread-safe versions of collection. Importantly, the collections class does not implement the collection interface, but it works with all types of collections in the framework, including list, set, and queue. It provides methods to manipulate these collections in various ways. Some of the most common methods provided by the collections class are sort, sorts element in a list in ascending order. Shuffle, randomizes the order of elements in a list. Reverse, reverses the order of elements in a list. Synchronized list, creates a synchronized thread-safe list. Max and min, returns the maximum or minimum in a collection based on natural ordering or a comparator. Let's create a list of integer nums equals new linked list and also add few elements to this list. We'll be adding some random elements. Now we will use the collections class to perform various operations on this list, starting with the shuffle method. Collections dot shuffle nums, printing nums. It has produced a random output for the list. If we rerun the program, this order will be different. You can see every time we rerun, there is a different output. The shuffle shuffles the elements. Next method will cover as sort. Collections dot sort nums. Collections dot sort have sorted nums in ascending order. Reverse method. Collections dot reverse nums. Reverse reverses the order of collection elements. Max and min. Max is collections dot max nums and min is collections dot min nums, printing the max and min element. We can see here the maximum element in the list is 81 and the minimum element is 4. Thread safety in collections. What is thread safety? Thread safety is a concept that ensures a collection behaves correctly when accessed by multiple threads in parallel. It prevents issues like data corruption or inconsistent results when several threads are modifying or reading from the same collection. In a multi-threaded program, thread safety ensures that the collection remains in a consistent state regardless of how many threads are accessing it. Without thread safety, different threads may interfere with each other, leading to unpredictable behavior. Java provides several thread-safe collections, such as vector and hash table, which were designed for thread-safe access in earlier versions of Java. Collections.synchronized list, which wraps existing collections to provide thread safety. Concurrent collections like concurrent hash map, which allow efficient thread safe operations without locking the entire collection. Performance considerations. When choosing the right collection for your program, performance considerations play a crucial role. Different types of collections offer different trade offs in terms of performance, so you should choose the right collection based on your needs. ArrayList is great for situations where you need fast random access and frequent insertions at the end of list. However, inserting or removing elements from the middle or beginning is slower due to the need to shift elements. Linked list is better suited for cases where you need to frequently insert or remove elements at the beginning or end of the list, as it does not require shifting elements like ArrayList does. However, random access is slower compared to ArrayList. Hashset is ideal when you need to store unique elements and want fast lookup and insertion times, typically constant for both. However, it does not maintain order. TreeSet offers sorted order of elements, but may have slower performance compared to hashset for basic operations like lookup and insertion due to its underlying tree structure. For thread safety with minimal performance overhead, you can use collections from the concurrent package, such as concurrent hash map. These collections provide thread-safe operations while ensuring that performance is not significantly impacted. Thanks for watching. That's it for this video. Don't forget to like, share and subscribe. We'll see you in the next one.